Happy morning to all my dear students. Welcome to K-Tech High School and Junior College. Children, we have already started our lesson number 1, Laws of Motion from Science 1. And in our previous lectures, we have studied about distance and displacement, and also we have studied about speed and velocity. Children, in today's video, we shall be learning uniform and non-uniform linear motion. So, let's begin. Children, now here we have Amar, Akbar and Anthony. They are traveling in different cars with different velocities. Okay? Amar, Akbar and Anthony. They are 3 friends and they are having 3 cars. They are traveling in 3 different cars with different velocities. Now the distance covered by them during different time intervals are given in the table. Look here in this table. The distance covered by them during different time intervals are given here. First we have time in the clock. Second column we have distance covered by Amar in kilometers. Third column we have distance covered by Akbar in kilometers. And in the fourth column we have distance covered by Anthony in kilometers. So at 5 o'clock, Amar, the distance he discovered is 0. Same for Akbar and Anthony. Now at 5:30, okay, 5:30, distance covered by Amar in kilometer is 20. By Akbar it is 18 and by Anthony it is 14. Now at the time interval of half an hour, after half an hour, that is 6 o'clock, Amar has covered the distance 40 kilometer, Akbar 36 kilometer and Anthony 28 kilometer. So children, you will observe that there is an equal time interval, right, of 30. Children, by observing this table, let us answer some questions. What is the time interval between the notings of distances made by Amar, Akbar and Anthony? So what is the time interval, children? Yes, it is 30 minutes. After every 30 minutes, the distance covered by Amar, Akbar and Anthony are being noted. Next, who has covered equal distances in equal time interval? Can you tell me, children? Yes, absolutely correct. It is Amar. Amar has covered equal distance. How much? That is 20 kilometers in an equal time interval of 30 minutes. Now children, tell me, are all the distances covered by Akbar in the fixed time intervals the same? No. The distance covered by Akbar is not in a fixed time interval. Now considering the distances covered by Amar, Akbar and Anthony in fixed time interval, what can you say about their speed? So, Amar, there is a constant speed, okay, while speed is changing in Akbar's and Anthony's. Are you getting me, children? Have you understood how we have answered the questions given here? Okay. Now children, if an object covers equal distances in equal time interval, it is said to be moving with uniform speed. I repeat, if an object covers equal distance, okay, when an object covers equal distance and equal time, equal time interval. So it is said to be moving with uniform speed, that is same speed. Okay. So here Amar, okay, Amar is covering equal distance in equal time interval, right? He is covering 20 kilometers distance in a 30-minute time interval. So Amar is said to be moving with uniform speed. Have you understood, children? What do we mean by uniform speed? Uniform: if an object covers equal distances in equal time intervals, it is said to be moving with uniform speed. Now children, if an object covers unequal distances in equal time intervals, it is said to be moving with non-uniform speed. Now as you can see in the picture also, there are two cars and a truck, right? And they cover an unequal distance but in a say equal time interval. Okay. In the same equal time intervals, there are unequal distances covered. So this is known as non-uniform speed. I repeat the definition. If an object covers unequal distances in equal time intervals, it is said to be moving with non-uniform speed. Understood, children? Let's take an example to understand this non-uniform speed. The motion of a vehicle being driven through heavy traffic. Now here, as you can see, there is a heavy traffic. So the motions of the vehicle here shows an example of non-uniform speed. I hope you all have understood uniform and non-uniform motion. Good, children. Let's move to the next topic. Next topic we are going to learn is acceleration. Let us see what does it mean. Now let's try an activity to do this, to understand this. We will take a 1 meter long plastic tube and cut it lengthwise into two halves. Now take one of the channel shaped piece, place one of its end on the ground and hold the other at some height from the ground. Okay. Now as it is shown in the figure. Take a small ball and release it from the upper end of the channel. So what will happen then, children? The ball will come down, right, through that channel. So observe the velocity of the ball as it rolls down. Now is its velocity the same at all points, children? No, the velocity will not remain the same. Initial, at the first point, it will be 0. At the middle, when it comes, it will increase. But as it reaches to the ground, its velocity will again decrease. Now observe how the velocity changes as it moves from the top through the middle and to the bottom. Let us learn one more example to understand what is acceleration. Now children, you must have played a slide in a park. Yes, you must have visited park and you must have played the slide. Now what happens when you play a slide? You know that while sliding down, the velocity is less at the top, right? The velocity will be less at the top. It increases in the middle, right? As you are in the middle of the slide, the velocity will increase. And then children, it becomes 0 towards the end, right? It becomes 0 towards the end. So children, the rate of change of velocity is called acceleration. Understood what is the meaning of acceleration? It is the rate of change of velocity. Okay, now here the velocity at the top, it is 0, it is less, right? And when it reaches in the middle, it increases and becomes 0 towards the end. So here there is a change in velocity. So acceleration is the rate of change of velocity. So here is the formula for acceleration. Acceleration is equal to change in velocity upon the time required. Now if the initial velocity is u and in time t changes to final velocity v. Okay, so how we will derive our formula? Acceleration, that is a, will equal to final velocity minus initial velocity upon time. Therefore, we will now substitute the variables. So, therefore, a is equal to v. V is what? Our final velocity minus u. U is what? Our initial velocity upon time t. So, this is the formula for acceleration. Understood, children? Okay. Now, children, if the velocity of an object changes during a certain time period, then it is said to have accelerated motion. Are you getting me? If the velocity of an object, it is changing during a certain period of time, okay, then it is said to have accelerated motion. An object in motion can have two types of acceleration. Let us see what are those two types. Now look here, children. If the velocity changes by equal amount in equal time interval, okay, I repeat, if the velocity changes by equal amounts in equal time interval, so the object is said to be in uniform acceleration. Did you got me? Okay. Now children, if the velocity changes by unequal amounts in equal time interval. Now here the velocity is changing by unequal amounts in equal time interval. So the object is said to be non-uniform acceleration. So are you looking at the figure here? The velocity is changing, right, by unequal amount in equal time interval. Therefore, the object is said to be non-uniform acceleration. Okay, children? Let's move to the next topic. Positive, negative and zero acceleration. Now, let's see what it is. An object can have positive or negative acceleration. When the velocity of an object increases, okay, when the velocity of an object, here the object is the car, okay, so when the velocity of an object increases, so the acceleration is said to be positive, okay. When the velocity of an object increases, it is said to be that the acceleration is positive. Now in this case, acceleration is in the direction of velocity, right? The acceleration is in the direction of velocity. Now when the velocity of an object decreases with time, it has a negative acceleration. Now what do we say for negative acceleration? When the velocity of an object, here the object is a car, when it decreases with the time, so it is called as negative acceleration. This negative acceleration is also called deceleration. Okay? Its direction is opposite to the direction of velocity. So if the velocity of the object does not change with time. It has zero acceleration. So when does an object has zero acceleration? If the velocity of the object does not change with time. So it is said to be that it has zero acceleration. Okay, children? If the velocity of an object does not change with time, it has said to be zero acceleration. Moving to the next subtopic, distance time graph for uniform motion. Okay, we have just learned what is uniform motion. Now let us plot a graph for distance and time. Now this table shows the distance covered by a car in a fixed time interval. We need to draw a graph of distance against time on along the x-axis and distance along the y-axis. Okay. Now look here, what are the readings here? Times in seconds is 0, 10, 20, 30, 40, 50, 60 and 70. Whereas distance is taken in meters, it is 0, 15, 30, 45, 60, 75, 90 and 105. So we need to plot a graph. Now if we see the x-axis, okay, it has time in seconds and on y-axis we have distance in meters. Now if time 10 is taken, so what is the distance? 15. So we need to make a point over there as it is shown in the figure with the red colored dot. Same way we need to plot for 20 seconds, it takes 30 meters. The same way we need to follow till 70. Okay. So when we join the dotted line, this is how we observe the graph of time distance for uniform motion. So children, an object in uniform motion covers equal distances in equal time interval. Thus the graph between distance and time is a straight line, as you can see here, children. So understood why this graph is in straight line? Because an object in uniform motion covers equal distances in equal time interval. Understood, children? How to plot the graph of distance and time for uniform motion. Let's proceed further with distance time graph for non-uniform motion. Now children, the table shows the distances covered by a bus in equal time intervals. We need to draw a graph of distance against time, taking the time along the x-axis and distance along y-axis. Now here if we plot the graph, times in second is 0, 5, 10, 15, 20, 25, 30, 35. So there is an equal time interval of 5 seconds. Okay. And distance covered is 7, 12, 20, 30, 41, 50, 58 respectively. So here if we make a graph, okay, if we mark the points accordingly with the time and the distance covered, we get a graph like this. Okay, so here the distance changes non-uniformly with the time, right? Time interval is equal, but the distance covered is not equal. So the distance changes non-uniformly with the time. Thus we can say that the bus is having non-uniform motion. Understood, children? Understood the topic, how we have plot the graph of distance time for non-uniform motion? Okay, good. The next topic is velocity time graph for uniform velocity. Now here we are doing velocity against time. Okay. Now children, take an example. A train is moving with a uniform velocity of 60 km per hour for 5 hours. Okay. The velocity time graph for this uniform motion is shown here. So, here we have x-axis, that is time in hours, okay, and on the y-axis we have velocity kilometer per hour. So, the scale for x-axis is 1 centimeter equals to 1 hour and y-axis 1 centimeter is equal to 10 kilometer per hour. So, we have plotted the graph for 2 hours, okay. So, what is the distance? 60, right? And after 4 hours, it's at point B, okay. So, with the help of the graph, how will you determine the distance covered by the train between 2 hours and 4 hours? Now, is there a relation between the distance covered by the train between 2 hours and 4 hours and the area of particular quadrangle in graph? So, what is the acceleration of the train? So, we need to calculate by using the formula for acceleration, that is change in velocity upon time, the initial velocity and final velocity. Okay children? Velocity time graph for uniform acceleration. Now children, the changes in velocity of a car in a specific time intervals are given in the table shown here. Okay, time in second and velocity in meter per second. So, here we can say that the time in second is 0, 5, 10, 15, 20, 25, 30, 35. So, there is an equal time interval of 5 seconds, right? And here velocity is 0, 8, 16, 24, 32, 40, 48, 56. That means here also there is an equal velocity, right? The difference is 8 meter per second. So the velocity time graph would be like this. On x-axis we have times in second. On y-axis we have velocity meter per second. Children, the velocity changes by equal amounts in equal time interval. Yes, we have just seen here equal time interval of 5 seconds and velocity is 8 meter per second, right? So thus this is uniformly accelerated motion. Understood children? For all uniformly accelerated motion, the velocity time graph is a straight line. Always remember this children. For all uniformly accelerated motion, the velocity time graph will always be a straight line. Okay? For non-uniformly accelerated motion, the velocity time graph may have any shape depending on how the acceleration changes with the time. If the graph is of non-uniformly accelerated motion, so the velocity time graph may have any shape depending on the acceleration change in time. Okay? Now, from the graph, we can determine that the distance covered by the car between 10th and the 20th second, as we did in the case of train in the previous example. The difference is what? It is that the velocity of a car is not constant, right? The velocity is not constant, but in the train it was constant and continuously changing because of uniform acceleration. Now in such a case, we have to use the average velocity of the car in the given time interval to determine the distance covered in that interval. Now children, from the graph, the average velocity of the car would be 32 plus 16 upon 2. When we calculate this, we get 24 meter per second. Now if we multiply this by the time interval, what is the time interval? 10 seconds. It gives us distance covered by the car. So distance covered is equal to 24 meter per second into 10 seconds, which we get the answer as 240 meter. Okay. Now check that. Similar to the example of the train, the distance covered is given by the area of quadrangle ABCD, which you can see in this graph. Which graph? Time velocity graph. So we can say that area of quadrangle ABCD is equal to area of quadrangle AECD plus area of triangle ABE. Okay. How we will find by this formula? Look at this children figure. I am repeating, area of quadrangle ABCD. It is a quadrangle, right? So it is equal to area of quadrangle AECD plus area of triangle ABE. Understood children? I hope I have made myself clear, and I also hope children you have understood today's topic. Children, after watching this video, kindly read the lesson, okay, so that you understand it more clear. Thank you students. We shall see you in the next lecture with a new subtopic. Till then, take care of yourself and your family. Stay connected children. Thank you.